Do you feel the vibes?
Hi everyone. Sorry I'm not there today, but let's go ahead and do section 8.2. So today we're going to focus on adding and subtracting rational expressions or fractions, right? So to add or subtract rational functions or expressions, they have to have the same denominator. If they don't, what we have to do is we have to find the LCM of the denominators first and then make sure we make them the same denominator. So in this first case, I have a 6 and a 9. Now between the 6 and the 9, the LCM is 18, right? So this LCM is going to be 18. Now what we would have to do is, what can I multiply the first one to make it 18? Well, that's 3. So I multiply top and bottom by 3. What can I multiply the second one to make it 18? 2. So I multiply top and bottom by 2, and then I continue from there. All right, we'll do more of that in a little bit. When you have a situation like this is not as simple as the 6 and the 9, but it can be. So what we're going to do here is, first, we're going to factor. When I factor this, xx minus 2 minus 1, here I get 2x squared minus 1, which can factor some more, 2x minus 1, x plus 1. So to make the LCM for this one, here's what we have to do. You have to first deal with the coefficients. So in this case, the only coefficient here is this one, right? Which is a 2. So here I take that one. If there was another one, I would have to do the LCM. Now, what else do I have here? Well, I have an x minus 1. I have an x minus 2. And I don't have another color. I have an x plus 1. So do you see how I have 3 different types of expressions? It's like 3 different types of products in a store, right? You go to a store and they happen to sell x minus 2s, x minus 1s, x plus 1s. In your common denominator, all of these must be represented. So I take an x minus 2, an x minus 1, and an x plus 1. All right? So your common denominator has to include or represent everything that is in your respective denominators. Okay, so here, let's go over here and see how we can get an LCM of each of these. So first of all, I have some coefficients here. I have a 15, I have a 16, and I have a 20, right? So between the 15, the 16, and the 20, right, is actually 240. Okay? All right, next. I know that's a bigger number than we're used to, but generally they won't be that big. Okay, next, take a look at what we have. We have some a's here. I have an a squared and I have an a cubed. If you have the same base but different exponents, you have to take one with the higher exponent. Okay, now I have, what do I have? I have a b to the 5. Between the two of them, I take the one with the highest exponent. And then I have a c cubed, a c squared, and a c to the 6th. You guessed it, we're going to take c to the 6th because that's the highest exponent. That would be the LCM. Okay, here, these need to be factored. So for this one, first I factor out an x. I get x squared minus x minus 2. This becomes x minus 2, x plus 1. For this one, I factor this out, and this is going to be x minus 2, x minus 2. So really, that's x minus 2 squared. Okay, so now let's see what we have here. We have an x, right? So we take one of that. We have an x minus 2 and an x minus 2 squared. Between the two of those, I'm going to take the one with the higher exponent. And then I have an x plus 1, so that would be my LCM. Notice every single type is represented, and I have the highest exponent if there are repeats. Okay, so here too, let's find the LCD. All right, so I have 4 over 6, 4 over 9. I look at the denominators. Between the 6 and the 9, we said the LCD was 18. We just did that before. Here, I have one denominator of x, x plus 1, x plus 1, x minus 2. Here, this is just a whole number, but it has a denominator of 1. Okay, so what is the LCD here? I don't have any coefficients other than the 1, so I can ignore that. But again, I have an x, I take one of those. I have an x plus 1, an x plus 1, I take one of those. And I have an x minus 2, I take one of those. This is the LCD. All right, so to add and subtract rational expressions, this is the first step, is to find the LCD. Once we've done that, we have to now rewrite each expression with the LCD. Okay, we have to make common denominators. All right, guys, let's do it. I am so excited. Okay, all right. So between the 6 and the 14, all right, if you're having trouble coming up with a 6 and a 14, what you can do is the 6 is actually 2 and 3. The 14 is a 2 and a 7, right? So again, we take one of each. I have a 2, I have a 3, I have a 7. And if I multiply all of those, that gives me a 42. Okay? So here, the common denominator between the 6 and the 14 is a 42. Okay, next, I have some A's and I have some B's. I have an A squared. I take one of those. I have a B and a B squared. So which one do I take? That's right, the one with the higher exponent, B squared. Now, the next step is, just like we did here, I have to say, okay, what can I do to this to make it 18? Well, that's multiplied by 3. Okay, here, what can I multiply this by to make it a 42a squared b squared? Well, to make it a 42, I need to multiply by 7. And then I need to multiply by a squared and a b. 7a squared and a b. Okay, the next one, here, the 14. I need to multiply that by a 3 to make it 42. What else do I need to multiply by? A squared, b squared, these are all the same. I don't need to multiply by anything, so just 3. Okay, so let's see here. What do I have in the numerator? 7 times 5, 35. A squared times a squared, a to the 4, times b, plus 9 times 3, 27. All right, and it looks like that's it. That's actually my answer there. Okay? All right, let's do another one. Here, I need to factor first. All right, 3x minus 5. Here, 6x minus 5. So, this is equal to, all right, let's see. Let's see what we can make as the common denominator. Isn't that cute how they both ended up with an x minus 5? Oh my goodness. Okay, so between the 3 and the 6, what's the common denominator? 6. X minus 5, x minus 5. So I just take a sample, an x minus 5. Okay, so to make the first denominator equal to 6x minus 5. What do I multiply by? 2. 2. Remember to put this in parentheses. Here, 6x minus 5 is already 6x minus 5, so I don't need to multiply by anything. But remember to put that in parentheses as well. So distribute the 2, 2x plus 20. Now we have to distribute the minus. So minus 3x minus 15. Okay, what do I have now? 2x minus 3x, that's negative x, plus 20 minus 15 plus 5 over 6 x minus 5. Okay, there's a little bit of a situation here, a little bit of a plot twist, because take a look. What if I just switched the orders here? Okay, so I wrote 5 first, then plus negative x. Is that what that would look like? It is. Over 6 x minus 5. Now, take a look at those two. Do those cancel? They do, because you're subtracting the same thing but in reverse order. They do cancel, but there is a fine of negative 1. So finally, I have negative 1 over 6. Talk about a plot twist. Who would have thought all that would just reduce to negative 1 over 6? I didn't. Okay, let's continue. Here, what will be the common denominator? Well, I have an x plus 1, I take one of those. I have an x plus 2, I take one of those. Here, what do I multiply this denominator by to make it look like this new one? Nothing, it's already the same. Second one, what do I multiply the x plus 2 by to make it look like this? X plus 1. X plus 1. Don't forget those parentheses, guys. They are so important. Okay, so here I have x. Now, here, I need to distribute minus 4x into this. Okay, so basically what I have is minus 4x times x plus 1. That's easier to see, I think. So distribute the minus 4x. I have x minus 4x squared minus 4x all over x plus 1, x plus 2. Okay, what do we have here? The x and the minus 4x is minus 3x minus 4x squared, x plus 1, x plus 2. All right. Here, why don't we factor out a negative x? I have 3 plus 4x, okay, over x plus 1, x plus 2. Now, can I cancel anything out? I can't, so I'm done. All right. Also, if we were not going to cancel anything out, you could have also, left it this way or this way. If by factoring something out, you are not going to be able to reduce further, you are not required to factor out. Okay, let's take a look at this one. What are we going to do first, guys? Oh my God, I can hear you. You're saying we need to factor the denominator. So let's do it. Okay, x. Ooh, plus 6 plus 3 adds to 18, adds to 9, multiplies to 18. And then here I have an x plus 6. Okay, so what's going to be the common denominator? Well, I have an x plus 6 that needs to be represented, an x plus 3 that needs to be represented in my denominator. Right, what do I multiply the first one to make it look like this? Nothing. What do I multiply the second one to make it look like this? X plus 3. Don't forget the parentheses. They matter. So let's see what we have left. 4x plus 5, x plus 3. Okay, let's see. Distribute the 5. I have 4x plus 5x plus 15 over x plus 6, x plus 3. Next, combine these two. 9x plus 15 over x plus 6, x plus 3. Okay, so now you ask yourself, wait, is there anything I need to factor out? Well, let's see. All right, if I factor out a 3 from the top, I get 3x plus 5. In doing that, am I going to cancel anything from the numerator with anything from the denominator? I'm not. So I actually don't need to do that. Okay? My sisterly advice to you would be don't do any extra steps, because if you got it correct up to here and then you went and you did some more steps and you did it wrong, then I have to take points off. Okay? So quit while you're ahead. Okay? All right. Okay, let's do another one. Oh my gosh, you guys have no idea how much fun I'm having right now. Like, so much fun. I love this stuff. Okay, let's do it. All right, let's factor this. Two numbers that multiply to negative 6 add to negative 1. That's right, negative 3 plus 2. Here I factor out a 5, x plus 2. Oh my God, we keep ending up with like the same terms. Wow. Okay, so what's going to be the common denominator here? I have an x minus 3 that needs to be represented. I have an x plus 2 that needs to be represented. And I have a coefficient of 5 that needs to be represented. Right. So the first denominator, right? Compare it with my new denominator. What is it missing? What should I multiply by to make it look like this new one? Yep, a 5. Good. Don't forget the parentheses. Okay, what about the second one? What should I multiply the second one to make it look like this? Yes, x minus 3. Yay! Okay, so I think I'm being too loud. I'm actually making the screencast in one of the offices, in the faculty office. I think I'm being a little too loud, but you know what? It's okay. People can get excited about math. Let's do this. Okay, so what do I have? 5, x minus 1, minus 4, x minus 3. Can I just stop here and comment on how important it is for you to have proper bookkeeping, right? To be neat and ordered so you don't lose track of these terms, because it's a lot. It's a lot of things to keep track of, but it's okay. We can do it. Let's distribute. 5x minus 5. Distribute the minus 4. Minus 4x plus 12. 5x minus 3, x plus 2. Okay, what do I have? 5x minus 4x is x plus 7 over 5, x minus 3, x plus 2. Can I cancel anything out? I cannot, so we're done. Okay, last one. All right, let's see how we can factor this. Okay, we have a 4 in front. It's okay, let's multiply it to this. Now, two numbers that add to 21 and multiply to 20. So that's going to be, oops, this went away. X plus 20, x plus 1. Let me actually write that in a better way here. Now, here's what we always forget to do. You got to put the 4 back. Put the 4 back. So I have x plus 5, 4x plus 1. Okay, so because this took so many steps, I'm actually just going to rewrite my two equations. My two equations all over again here. My two fractions. So what am I starting with? I have x minus 8 over x plus 5, 4x plus 1. Okay, I'm not doing any math in this particular steps. I'm just rewriting. So here, 6 over 12x plus 3. But can I factor out a 3 here and make it 4x plus 1? Of course I can. Okay, so let's see. What's going to be the common denominator? So I have an x plus 5 and a 4x plus 1. Oh, and I have a 3. I put the 3 here. Don't let this happen to you guys. Don't forget about that 3, right? You got to put the 3 in here. Okay, the first denominator. Compare it with this new denominator. What does it need? A factor of 3. 3. Don't forget the denominator. I'm sorry, don't forget the parentheses. Here, what can I multiply by to make it look like this? X plus 5. So, 3x minus 8 plus 6, x plus 5. This is going to be, let's see, I distribute the 3x minus 24, distribute the 6, over 3x plus 5, 4x plus 1. Okay, let's see. I need more space. The 3x plus the 6x gives me 9x plus 6 all over 3x plus 5, 4x plus 1. And again, if I factor out a 3 from here, am I going to have anything to cancel? No, so I just leave this as my final answer. Okay? All right. This has been so much fun, guys. And you can start on your homework right after this. Thank you.
Press start.